Let's work through some examples of simplifying radical expressions. Suppose you're asked to simplify and rationalize all denominators. Consider the square root of 2a divided by 175. Now the first thing I'm going to do is just write that as the square root of 2a over the square root of 175. And now when I want to simplify this, I'm looking for perfect squares that I can pull out of the square root. So I can't do anything to the top, but I notice that 175 is 25 times 7, and 25 is a perfect square. So the square root of 25 is 5, so I pull that out of the square root on the bottom, and I'm left with the square root of 2a over 5 times the square root of 7. Next, we have to rationalize the denominator. And so we have the square root of 7 on the bottom that we need to rationalize. I don't want to change the value of the expression, and so I'm going to multiply by the square root of 7 on the top and on the bottom. So when I do that, the square root of 7 multiplies on the top by the square root of 2a to give me the square root of 14a. And on the bottom, the square root of 7 and the square root of 7 give me 7. And so on the bottom, I'm left with 5 times 7, which leaves me with the square root of 14a all over 35. Let's consider another example, this time with just all numbers. Suppose we're asked to simplify negative 3 square root of 5 times 4 square root of 15. And now let me combine the minus 3 and the 4. And so it's a negative 3 times 4. And now I'm going to look at the square roots. So I have a square root of 5 and a square root of 15. The negative 3 times 4 is a negative 12. And the square root of 5 times the square root of 15 is the square root of 75. And now I notice, if I want to simplify this, I'm looking for perfect squares to pull out of the square root. 75 is just 25 times 3. And the square root of 25 is a 5. And so now I can combine the 5 and the negative 12 to get negative 60 times the square root of 3.